On Tuesday, August 24th at 2 p.m. CEST, the Qest conference will open with our presentation on a modest approach to dynamic heuristic search in probabilistic model checking. We present a tool using heuristics to avoid the state space explosion problem when model checking MDPs. We modified, adapted and extended the procedures known from the planning community to efficiently check reachability, expected reward properties and bounded versions thereof on general MDPs. Originally, these approaches were limited to checking the maximal goal reachability probability on specific MDP structures. The approach is implemented in Modish, which is part of the Modest toolset. The current version of the tool is available online. During the talk, we will demonstrate on several examples how our adapted and extended implementations of the original algorithms works. The results of our large comparative study impressively show that Modish is competitive with the state-of-the-art model checkers. It even outperforms them on very large state spaces, demonstrating that planning techniques can indeed be used to enhance the performance and capabilities of model checkers. If you want to know more about this promising approach, come to our talk.
Welcome everyone to this teaser video about parameter synthesis. So if we have a DTMC in which the probabilities are not fixed, so we have these parameters P and Q here, then we want to find out for which values of P and Q some property, some reachability property is violated or satisfied. In Storm, this has been implemented in the following way. So what we do is we divide the entire parameter space into regions in which all parameters violate the property, here in red, or satisfy it, here in green. And this has been formalized and implemented for MDPs and DTMCs. However, we want to now formalize this for PTAs as well. So the regular approach for PTAs without parameters is to convert them to MDPs to be able to solve them for the probabilities. However, if we have a parameter like we do have, for example, in this PTA, then we have a PPTA. And what we want to find out is whether we can do this conversion still from PPTA to PMDP, so that we then can obtain a parameter space partitioning from this PMDP. We also want to find out whether this entire approach is feasible.
My name is Samuel Teuber, and I'm presenting our work on quantifying software reliability via model counting. In our work, we are interested in programs like this one, where we have certain assume statements which constrain the input and assert statements which specify certain program behavior. However, instead of ensuring that this specification is always adhered to, we are interested in the number of input values which make the program fail. For example, in this case, we might be interested in the number of inputs which produce a division by zero error. Our contribution is threefold. First, we present a novel and sound formal approach for the assessment of reliability according to adherence or violation of a specification, both for deterministic and non-deterministic programs using model counting. Secondly, we implement this approach into a pipeline. Our pipeline first performs a program transformation, then converts our program into propositional logic formula using CBMC, and finally uses off-the-shelf model counting tools to quantify our program. Finally, we evaluated our approach on a number of representative benchmarks and did a comparison to another approach by Dymowski and Legge.